Hi, I'm S.J. Park from LSE Electric. This seminar shows the FEM system, which includes all of infrastructures related to how to manage energy. First, why we should build a FEM system, and secondly, energy management system and critical power solutions. First, FEMs. The basis of energy has changed over the time, from thermal power to oil and nuclear power and renewable energies. Then the next energy, absolutely energy savings. Currently, it is possible to measure energy consumptions up to the terminal load according to IoT technology. And by using this big data, it is possible to establish a goal for overall energy saving. In addition, many technologies related to the AC-DC conversion have been developed to improve power efficiency. Globally, the regulation of greenhouse gases is being strengthened. In accordance with the Paris Climate Agreement, we are aiming to reduce greenhouse gases by 37% compared to BAU by 2030. Therefore, there is a need for energy countermeasure to reduce greenhouse gases in factories or buildings. In the era of unlimited competition, the need for energy-saving activities is increasing to enhance the cost competitiveness of companies. However, although energy-saving activities must be actively promoted, the reality is that it is not easy to know what kind of activities can be performed to save energy. Therefore, it is necessary to establish on energy infrastructures to digitize energy specifications and target quantities and establish such data. The energy saving paradigm is changing from saving to the efficiency and optimizations. Most companies have been adopted saving efficiency, and now is the time to pursue database energy reduction activities. For this, it is necessary to conduct optimizations activities through the energy monitoring and analysis of detailed consuming load. Secondly, what we have for energy management. FEMS is a total energy management infrastructures through management in the storage system, on-premises, and cloud. The field layer is a stage in which equipment data is acquired by adding IoT functions to all equipment required for the energy resources, production facilities, and utilities. The monitoring layer is the stage to measure, monitor, and control this IoT data. Through various analysis and diagnosis service, data-driven management was realized and expanded to cloud, enabling integrated management of multiple factories. The FEMS project begins with the IoT infrastructure, construction, and proceed with the procedure of FEMS constructions and follow-up diagnosis. Depending on the degree of solution sophistications, IoT infrastructures, construction measures, even the feeder load at the end of energy sources, and FEMS provide basic energy management functions and analysis prediction information based on big data. It analyzes data using result through FEMS and additionally drives insight for the energy improvement through the self-diagnosis. To build on IoT infrastructures, it is necessary to measure the energy and load in real time. Therefore, it is possible to measure even the feeder of distribution board using IoT devices such as GMAC-B. Through this infrastructure, it is possible to manage each feeder in real time in the field, and by transmitting all the data to the center, it is possible to derive overall energy's operation plan. The configuration of FEMS is also shown as a second step. It collects, saves, manages data from various energy sources, and shares data in various environments such as web client, mobile, in connection with the existing system. The practical function of FEMS can be divided into several stages. It consists of analytics and predictive functions from base data management collected through the infrastructure. It is divided into basic FEMs, which provide system management functions and part of analysis, and advanced FEMs, which include predictive functions. This screen is built in the form of a basic dashboard, and operators and managers can visually see current energy operation status. In particular, it provides screens for the energy use, area, and power system management. Can be customized according to the customer need. This screen is an operation screen for monitoring functions. This screen consists of detailed data inquiry and real-time alarm management screen. This is the operation screen for the management and analysis functions. It analyzes energy consumptions, including power qualities, to show the operational status. It is a service that diagnoses after construction of FEMs. It proceeds to the stage of acquiring raw data and analyzes abnormal situations and causes, deriving improvement plans, and analyzing business feasibilities, and finally proposing practical operational plans. This service is provided to the customer with insufficient diagnostic capabilities, usually carried out after 1 year FEM's operations, and analyze accumulated data to derive improvement plans, and if necessary, even offer suggestions for the implementing improvement plans. Third, critical power solutions. Critical power solutions include technical solutions that can provide continuous power and respond to accidents in any situations. In general, advanced switchgears are divided into closed switchgear that can withstand arc resistance accidents, and switchgear that limit arc resistant energy to protect devices. Let's see the actual test result for each step. The first test is for the standard type. The second, arc-proof switchgear. Third, arc-eliminated switchgears. Arc-eliminated switchgear protect live and the devices as well. The arc-resistant switchgear conforms to the IEC 62271 standard while reducing the size of the existing switchboard to 64%. It is a product that can perfect facilities and people by separating each important area into a separate arc-resistant type to prevent transfer of the accidents by area as much as possible. The arc-limiting switchgear can minimize the arc energy by grounding the arc energy even if an arc occurs. The arc energy peaks at 15 milliseconds, but by extinguishing the arc before that, it prevents expansion into accidental energy. This switchgear is especially designed to safely protect the facilities in the factory, even in an earthquake. The seismic test is an international IEC standard, and the proof test is actually performed through a horizontal and vertical test at an accredited testing laboratory. Critical power is required to operate 24 hours, 365 days per year. Therefore, accidents can be prevented in advance by diagnosing equipment even if in live state. Currently, power discharge, thermal imaging camera, and temperature sensors are built in the switchboard to prevent major accident in advance. An accident in a distribution facility directly leads to the fire. Therefore, it is possible to monitor in real time by installing a contact-type wireless temperature, infrared camera IR sensor, and a breaker temperature sensor that can directly check the temperature inside the switchboard. Unlike the old high voltage and low voltage panels, smart functions are being reinforced. Detailed power status measurement is possible, and even facility diagnosis information is delivered to the host system or operator in real time through the IoT communication environment. In addition, facility managers can easily check the facility status through the mobile devices at a short distance. The smart MVLV system maximizes the availability of power facilities and enables stable operations through facility diagnosis and predictive maintenance. In addition, maintenance convenience and energy efficiency can be improved, which is a basic step toward the energy saving. From the high voltage switchgear and transformer to the low voltage switchgear, motor control center, and distribution board, and the IoT environment is built by composing products that implement the IoT functions. Each facility has a built-in Bluetooth and Wi-Fi communications, and so it can be managed directly in the field, and all status and diagnostic data can be transmitted to the upper level system in real time. These measured data are later accumulated as a big data and used to analyze energy use and establish and reduction plans. Currently, energy supply and demand is possible from various renewable power sources. At that point, energy is saved by choosing the most economical way. By utilizing the ESS functions, electric bills can be reduced in real time, and the image as an eco-friendly company can be promoted. This is the end of FEM's introductions. Please contact me if you need any more information. Thank you.